Hey everyone, my name is Jorge Acosta. I'm a partner of Wenlong, and this is our Python presentation. So we'll be doing an overview of everything about Python, history, major evolutions, past status to current status, industry impact, paradigms, data types, control flow, expressions, object orientation, exception handling, optimization, and the medium program that we use. For history of Python, created by Guido van Rossum, SCWI in the late 1980s. That's in the Netherlands. And first started as a side project to fix the limitations of ABC. And whenever he first released Python 0.9.0, it was 91. And this came with the bare bones of the classes, inheritance, exceptions, functions, and core data types. The main reason for Python getting started was to fix the readability, simplicity, and flexibility that ABC didn't have. So some of the major evolutions, as stated, Python 0.09 came out in 94, 91, correction. 1.0 came out in 94, which added functional tools such as lambda, map, filter, reduce. Python 2.0 came out in 2000. This introduced list, comprehension, garbage collection, and Unicode support. The Python 3.0, released in 2008, has had major redesign, removing outdated features and improved consistency. 3.0 became more modernized, and then eventually small features of 3.6 and 9 came out, and then 3.10 are the biggest evolution as of recent. It's 3.11, released in 2022. This had a significant performance boost, and it was up to 25 to 60% faster than 3.10. And you can see off to the right, just a little picture of some of the major evolutions. I didn't go over all of it, that take forever, but it's just some of the stuff with it. It was first released, the popularity was around 1%, went into the index, and then up until 2004, it had a jump of 6.5% popularity rating. And it was consistent, maybe rose a little bit. And once it hit 2018, there was a major surge of popularity in Python, reaching up to 26% by 2025. And since 2023, it's been ranked number one in programming language popularity. And the main reasons why it became so popular is the simplicity, adaptability, and the readable syntax, also the writability of it. Some of the industry impacts, it's widely used at major companies like Google, which supports Python for cloud tooling and infrastructure. Also, the Instagram, their backend, it runs entirely on Python. And Python's become essential in fields such as data science, machine learning, AI, web development, and automation. And as of right now, there's over a million global job postings in 2025 that list Python as a required skill. And as of 2025 as well, across the globe, there are over 8 million active developers that use Python. So that just shows you how much the industry uses it and how crucial it is across the globe. So some of the basic features, we got paradigms, it's multi-paradigm language. So that supports procedural programming, object-oriented programming, and functional programming. With the procedural programming comes with functions and scripts that execute sequentially. Object-oriented programming uses classes, objects. There's also functional programming. It goes through the first class functions, map, filter, lambda, etc. There's more to it. And some of the data types that we have for it. Um, Python has a large set of built-in data types, making it very simple to store information. We got numeric types, int, float, complex, text type, which str, which is just string formatting manipulation. Booleans, you have your true and false, makes it very simple. Then there's collection types. This is where a lot of the simplicity comes in and the readability. So list, you can think of it as arrays, stores items in a specific order, can remove or add elements. Great for data that needs to be updated or iterated through. So it makes it similar to arrays in C++. A tuple, items that should not be modified and protects data from accidental changes. Example, XY coordinates, RGB color values. So if you need a set value for an item, it'll be consistent the whole time. You really can't change it at all. So you can think of it as a constant almost. Third collection data type is set. So an unordered collection of unique items and great for removing duplicates and checking for fast membership tests. Uh, Great for removing duplicates and it's already set in there. So you can have a whole ton of names and everything. If you need to remove names out of the list, it's an easy way to do it. You have dictionary. As number four, a collection of key value pairs allows us to store search information by key instead of an index. So it's great for storing like student information, usernames, passwords. So you could have like student one and all their information. So instead of having multiple indexes, you have a single key for that. But also Python uses dynamic typing. So variables do not have to be declared. They'll be assigned automatically. So that's awesome. And you can see a great example on the side. So x equals 42. You don't even have to assign int, do that on float or anything like that as you would have to do in C++. And name, as long as you put the quotation marks right there, it's going to recognize Alice as a text type, a string. So you can see just some examples right there, how easy it is with data types here in Python. Moving on to control flow, Python uses simple English words to control the program logic. So we have else, well, we have if, elif, else, which is involved in decision making. We can see that in this picture to the right. So if x equals 10, if x is greater than 0, we can print positive. Elif x is equal to 0, we put 0. And if there's anything else that's below that, it's going to be negative. So it's very easy. Indentation makes it very easy to read. And then we have for and while loops. They're just involved in repeat actions as they would be in C++. They're also very simple. The syntax is very clean. Then there's break, continue, pass. These help refine loop behavior and actions. And then Python's famous indentation rules use white space, so that can be spaces or tabs, to replace curly braces, which is used to make clean and readable code. So if this were in C++, it'd be much bigger, it takes up way more lines. But since in Python, we don't use curly braces, it looks so much cleaner. And for expressions allows Python to compute values using operators such as the arithmetic ones, equal sign, plus, minus, times, uh, slash, slash for division, modulo, and the double star is power. You have comparison, which is must be exactly equal to with a double equal, not equal to, greater than, less than or equal to or greater than equal to. And we have logical and or not, and not reverses the condition. Also, Python supports expression-based features like list comprehensions, which creates lists in one clean line, makes code shorter and faster. We can see that off to the right, A is 7, B equals 3, and then C has a list of numbers and they're 1, 3, 5, 7. So that entire line, this could be in C++ about 15 lines, whereas in Python it's in 5, so makes it very simple. Subprograms in Python, you can use the def keyword to create functions, blocks of code that perform a specific task, normally called functions, but Python also supports specialized subprograms like methods, which functions inside of classes. This allows for code reuse, modular design, easier debugging, and it's always easier to do the try or accept. And Python also supports anonymous functions, lambdas for short, one-line operations. You can see off to the right over here some examples. You have the greet, makes everything so much shorter, so much cleaner. In C++, it'd be a little bit more complex, a little bit harder to read. This is what makes Python so great. Object orientation in Python, we treat everything, including numbers and strings, as an object. So programmers can define custom classes with attributes and methods. Supports key object orientation, concepts such as encapsulation, inheritance, polymorphism, encapsulation, building data and class functions, inheritance, creating new classes from existing ones, polymorphism, same method name, same method name behaving different in different classes. This is what makes Python great for building such large software systems. Off to the right, you can see the class and exactly what animal you want to make a sound. Then you can make class dog, which is under the class animal, but it'll be specifically for a dog. And that makes it so much more readable, cleaner. And then you just print, assign A and D to show to animal, then dog, print that out. And it comes out, animal makes a sound, and buddy barks. For exception handling, Python uses a clear structure for handling errors. You try to block the code that could fail. Then you could use an except, which is the second one, an action to take if it occurs. So you can see off to the right, x equals 1 divided by 0. And so you can't divide by 0. So if that except did happen, then we just print out cannot divide by 0. And finally is code that always runs. It just makes sure the code stays running. This helps prevent programs crashing unexpectedly and help isolate problems. And because it's already so simple, using the try and accept is very easy inside of the blocks of code that you will be using. And from here, Wenlong will take over.
Hey everyone, welcome to our presentation. I'm Wenlong and I'm doing the second half of our presentation. Okay, so right now we will begin with a quick look at optimization techniques in Python. So Python may not be the fastest language overall, but it makes up for it through several built-in optimization techniques. And first, many built-in functions in Python are actually written in C, giving them much faster performance. And it also provides efficient data structures like dictionaries and sets, which offer fast access and lookup times. And another key strength is list comprehensions and generator expressions, which help save both memory and execution time. All right, and there's finally Python's interpreter includes internal optimizations like caching and compiling code into bytecode. So this all techniques becomes very useful when we are writing medium-sized programs that work with a large amounts of text or data, just like the one we implemented for this project. So let's see our project. So the medium program we do is to demonstrate a real world program implemented in both Python and C++, and compare their syntax, efficiency, and their ease of use. So this program reads what do we like what do we do is write a program, reads a text file, counts the frequency of each word, and sorts the results in descending order. So writes the output to a new file and measures execution time. So this task allows us to observe how each language handles file like input and output, and data structures, sorting, and performance optimization. All right, so this is our implementation. This is the Python part. So the Python version uses the counter class from the collections module for frequency counting and the sorted for sorting. So we use the list comprehensions and built-in file IO. And as you can see on the right, this is our coding, and I split all the Python code like into different block. So this is every features of our the whole Python. So you can see we have like dynamic uh, typing and concise syntax. This is very simple, right? Just one picture. And I use built-in modulars like collections, time, and list comprehension for efficiency. And this is highly readable and minimal like boilerplate. And you can see like in Python, the core logic is very compact. I read the whole file, split it into the words, and then use the counter class from the collections module to get the frequencies in a single line. And I can then call sorted with a simple lambda to sort by frequency and write the results out. There's no need to declare types or manage complex data structures manually. So the code stays short and easy to read. This is highlights one key the advantage of Python. So it lets me focus on the problem itself instead of a boilerplate, which makes development much faster and more beginner friendly. All right. So this is all I use like the Python's pros and like cons. So Python can extremely concise. Python is extremely concise and readable. So building tools make implementation fast and also shorter development time. But it also has some cons like slightly slower runtime than compiled languages like C++. Okay, so this slide shows the equivalent implementation in C++. The C++ version uses if stream and upstream for file IO. We use map, we use map, we use different libraries and string, int for frequency counting, and vector used to pair string int for sorting. So we also use the chrono library for timing. And here you can also see there's two pictures of the right and have different just compared to the Python, it has like different features used. So we use like static typing and manual memory management, and we use different standard libraries from C++, like a standard template library, STL, map, vector, sort, etc. So also lambda expressions for like custom sorting. So for C++, it has like high control over performance and memory. And here I use if stream and upstream for file input and output and map. I use string, int, the different data types to count word frequencies, and then copy that into a vector. And so I can call like standard sort with a custom comparison lambda, and I also use the chrono library to measure execution time compared to Python. The C++ version is obviously I think is more verbose and requires explicit types and more setup. But I think it gives finer control over memory and performance, and it's better suited for like large scale or performances critical applications. So in this small text processing task, I think Python wins like in conciseness and development speed, while C++ is the language you would choose when you really need maximum efficiency. Okay. So this slide like tell us about the C++ features, and we talked that before. So it has more efficient for large scale data, and greater control over memory and processing. Also, it's also strong typing helps catch errors early. But there's also like coins like more verbal syntax and longer development time and requires more code for the same logic. So we can tell from the different pictures as we just use one picture for the Python, all the logic, all the coding block stuff. But we use two pictures and it's more complicated. And as you can see, there's more code block and for just for the same logic. And we use like different libraries to use these blocks. So this is the summary about our comparison to the Python and the C++. With Python version is short and concise, and building data structures and functions make common tasks more simple. But C++ is more verbose and explicit, and it requires additional code for standard operations. So Python was chosen for its simplicity and efficiency. Okay, this is our whole medium, the entire medium program. So we got the reflection is presenting our comparison of a Python and C++ was both enlightening and rewarding. We structured our talk to guide and to guide the audience through the core language features, real program implementation, and performance analysis using a word frequency counter. During the live demo, we showcased both Python and C++ code reading from the same input file, performing sorting and writing results efficiently. While also the measuring execution time, the execution time with just medium program is pretty similar. It's pretty similar, just like a million seconds. But also we can also tell from the different coding there's still some difference, and the audience respond well to the contrast between Python's simplicity and C++ control over the performance. And one of the key takeaways was how Python makes development faster and more intuitive, especially for data processing tasks. However, we also recognize the strength of C++ in terms of control over memory and execution speed. Reflecting on the experience, we felt the live demonstration if effectively like highlighted the trade-offs between the two languages and help reinforce our understanding of both. So this is the whole thing. In this whole presentation or this whole program, uh, the excerpts help us explore not only Python syntax but also its built-in strength like expressive data structures and high-level modulars. Um, by comparing it to C++, we got a deeper understanding of what abstraction and developer productivity look like in practice. So for tasks like text processing, Python's design truly shines for me. And project was a great opportunity to see those different in action. All right. This is the entire presentation of me and my partner So thanks for watching and hope you have a great day and a wonderful break. Thank you.